90 cities, one number each, average income. Stack that number into columns and count how many cities land in each one, and that's a histogram, the chart built entirely from counting. Watch this. Most cities cluster low, a handful climb far above the rest, and the whole shape leans right. Bins decide whether you see that lean clearly or miss it completely. By the end, you'll be driving that dial yourself. Scatter 90 income values on a line and you get noise, basically overlapping dots, no story. Group them into columns instead, and now you can see how many cities sit in each income range. That single choice, how wide each column is, decides whether you see a clean shape or a blur. This whole lecture is about mastering that one choice, the bin. 9 numbers summarize 90 cities. Minimum income is $2,300, maximum is $43,900. The mean sits at $14,700, but the median sits lower at $12,700. That $2,000 gap between mean and median, that's your first clue this dataset leans right, and the histogram you're about to build will show you exactly why. You only need 2 imports and 2 lines of real work to build a histogram. NumPy holds the income array, Pplot builds the figure, and hist does every bit of the counting for you, sorting 90 values into columns and stacking them without you writing a single loop. Everything from here is really just tuning the arguments you hand to that one function. 3 bins and every city crowds into one fat block. You can't tell coastal boomtowns from struggling towns. Push to 60 bins though, and each column holds barely 1 or 2 cities, all signal drowned in noise. Somewhere in between, around a dozen or so columns. There it is, the true shape appears, a tall cluster of modest incomes and a long thin tail reaching past $40,000. That tail's the skew. Instead of choosing how many bins, choose how wide each one is. Same decision, different dial. Set the width to $8,000 and the whole distribution folds into 5 fat columns, the skew flattened away. Shrink it to 30 cents on the dollar and you get a picket fence of 100 spikes, mostly empty. $2,000 a column is the sweet spot, enough columns to see the shape, not so many you're seeing noise. Income is built by multiplying growth rates together, not adding them. That's why it piles up low and stretches into a long right tail. Take the logarithm of every value though, and that multiplicative pileup turns into simple addition. The skewed hill on the left becomes something close to a bell on the right. Same 90 cities, same histogram machinery, one transform away from a completely different story. Look at just one number. The average income across these 90 cities is $14,700. Report that as typical, and well, you've lied by omission, because a handful of wealthy outliers dragged it upward. The median, $12,700, sits closer to where most cities actually live. Skewed data punishes the mean and rewards the median. The histogram's the only chart that shows you why. 4 bin counts, 1 dataset, 4 completely different impressions. 5 bins looks almost uniform, the skew vanishes. 12's the honest middle ground you've been watching all lecture. 30 starts revealing texture inside the tail. And 70 turns real structure into random noise. There's no single correct answer here, only a choice that matches the story you're trying to tell. Alright, check yourself on this one. 90 cities, 1 gap worth noticing. The mean income across this survey sits at $14,700, but the median sits lower at $12,700. That $2,000 difference between them is not random. It's a signature written into the shape of the distribution itself. So, what does that gap between mean and median actually tell you? It's the right skew, yes. A small number of unusually wealthy cities pull the mean upward, while most cities sit bunched together lower down. The median ignores those outliers and reports where the typical city actually sits, which is exactly why, for skewed data like income, the median is the more honest number to lead with.